Relative change. Another type of change that we can consider in calculus to study how different functions change is something called relative change. Consider this. If you received a dollar discount on some product, was that deduction a significant change? Well, the answer is that it really depends on what you bought. So consider the first scenario. You're buying a car that's listed as $25,000 on the lot. When you go in to talk to the dealership, they offer to sell it to you for $24,999. Scenario 2. You always stop to buy a medium iced coffee at Dunkin' Donuts for $2.64. Today they're running a promotion that all medium iced coffees cost $1.64. Now, in both of these scenarios, you received a $1 discount. However, one of them feels better than the other, as in it feels more significant. And the question is why? And the reason is relative change. Because for both of these products, we're saving $1, but that dollar is relative to the amount that the product costs. So we're going to explore how we can use relative change to look at various scenarios and talk about what it means in terms of the products and items that we are considering. Relative change, also sometimes referred to as percent change, is a mathematical way to compare two quantities while taking into account the size of the numbers being compared. So what that means is we're going to be looking at how much our price changes, but we're going to use a way to compare that with what the original price of the item was. So the way we write this formula mathematically is P1 minus P0 divided by P0. So let's talk about what these different things represent. P sub 1 is the new price that you're getting, either because the price has gone up or because the price has gone down. P0, which is the same thing as P sub 0, so P with the subscript of 0, is the original price that we're using as the basis to compare how much it's changed. Now, the top part, P sub 1 minus P sub 0, is called the absolute change. So if you're looking for the difference between two quantities, you would subtract them, and that's called the absolute change. But by dividing by the original number that we had, we're finding the relative change. So here, like I mentioned, in the scenarios we'll look at, there's going to be a change in price. We're going to reflect that in the numerator, and we're going to divide by the original price. It's important to note that the relative change is going to be a number without any units, and we often turn our result into a percentage, which means a lot of our results are going to be decimal numbers. So let's go ahead and look at a couple of scenarios where we can actually calculate this relative change using this formula P sub 1 minus P sub 0 divided by P sub 0. Example 1. Calculate the relative change for the scenarios presented above. Scenario 1 was that we were buying a car for $25,000 and the dealership offered to sell it to us for $24,999. So here, the original price was the $25,000. So in this case, that's our P sub 0, the original price. $24,999 is our new price that we're going to be getting if we decide to buy this car. So to find the relative change, we need to use the formula P sub 1 minus P sub 0 divided by P sub 0. So plugging in the numbers from our scenario, we get 24,999 minus 25,000, all divided by 25,000. It's important to remember which numbers go where, and that order is important. So here, when we carefully plug all of these things into our calculator, we're going to get negative 0.00004. It's a lot of zeros. So if we want to calculate that as a percentage, we would multiply that number by 100 to turn it into a percentage. So this is equal to 0.004% decrease. So it's a 0.004% decrease in price. So I'm using the word decrease to replace the negative. So I'm using the word to replace the symbol, but these mean the same thing. Now let's consider the second scenario. So our iced coffee that's normally $2.64, so that's our original price, today has a promotion where we're going to get it for $1.64. So that's my new price. So again, applying my formula, I'm going to do P sub 1, which is $1.64, minus P naught, $2.64, all divided by the original amount, $2.64. So again, I'm going to put this into my calculator. Turns out when I put it into my calculator, I get a lot of decimals, unlike the previous problem where I just terminated at 4. There were no other numbers after it. So here, what I need to do is I need to use the approximation symbol because I'm going to do some rounding. So here, I'm going to call this negative 0.3788. If I were to turn that into a percentage, which I'm usually going to do in this type of problem, I would multiply by 100 and I would get that this is approximately a 37.88% decrease in price. So again, I'm replacing my negative with the word decrease because when we talk about percentages, we don't usually use a negative sign with percentages. Instead, we use a word afterwards to indicate whether that number was positive or negative. So here you can see there's a very large difference in the discount we're getting in scenario 1 and scenario 2. In scenario 2, the discount is much larger, 37% approximately, compared to your 0.004%, which feels like nothing. So your gut reaction that scenario 2 you got a better deal is probably right when you think about the relative change. So again, when we have a negative, we're going to use the word decrease. If we had had a positive number, we would use the word increase at the end. Generally, we're going to put either increase or decrease at the end of our percentage to indicate what was happening. If there's no word present, then increase is implied. So if we had put 37.88% with no word and no negative, it would have been implied that it was an increase and would have been incorrect. So we need to make sure that we're using words to represent what's happening mathematically. Example 2. Find the relative change for each of the following scenarios if price increases by $4. So here we're going to have to do a little extra work to find our P sub 1. So scenario 1. There's a gallon of milk that costs $4. For this scenario, we're considering what would happen if the price increased by $4. So the original price was $4, and if we increase by $4, that means that our new price, our P sub 1, is going to be $8 because we add that 4 to the original cost. So now, when we plug this into our formula, P sub 1 minus P sub 0 divided by P sub 0, we're going to get $8, the new price, minus $4, the original price, divided by the original price of $4. And 8 minus 4 is 4, divided by 4 gives us 1. So we usually have decimal numbers, but we don't have to. We still want to turn this into a percentage by multiplying by 100, and that's going to give me a 100% increase in price here. So that feels like a lot. If we were normally used to paying $4 and now we're paying $8, the price has increased by 100%. Scenario 2. A Chromebook computer costs $150. So that's the original price, P naught, $150. Since we're considering what happens if price increases by $4, that means our P1 is $154 because we take our original price and we add that $4. So now, if we plug that into our formula, we get $154 minus $150, all divided by $150. So again, we're going to carefully crunch that number. We can simplify it first if we want to 4 over 150. And when we plug this into the calculator, we're going to get another long decimal. Since we're going to be rounding, I'm going to change this to approximate. And we're going to get 0.0267. and I'm cutting it off at 4 decimals. Here, if we turn this into a percentage increase, we're going to multiply by 100, and we're going to get 2.67% increase in price. So that feels less shocking. So a computer that's gone from $150 to $154 has a 2.67% increase, whereas a gallon of milk that went from $4 to $8 had a 100% increase. Example 3. Suppose that when a store sells a particular necklace for $60, they sell 65 per week. When they have their annual store sale, they reduce the price by 25%, and during that week, they sell 110 necklaces. Find the relative change in weekly sales. Now, this word problem is really interesting because there's a lot of information here, and we need to be really careful about what information we need and what's extraneous information. So let's go back to the question. Find the relative change, that's what we've been looking at, relative change, in weekly sales. So what we're comparing here are weekly sales. So the two numbers we have for weekly sales are the 65 necklaces per week at the regular price and 110 necklaces per week at the sale price. Those are the two numbers that we're going to need to find our relative change. In this scenario, the $60 and the 25% aren't giving us the information we need to find the relative change in weekly sales, so those are extraneous numbers. So I encourage you, when you're doing word problems, to make sure you understand the question and to underline what you think is the relevant information. So here, since we typically sell for $60, that means that the 65 necklaces per week is our original amount, because that's the amount we typically have and that we're comparing to. 110 necklaces is the new amount that comes with our sale. So when we plug this into our formula, we have P sub 1 minus P sub 0 over P sub 0. We're going to plug these numbers in just like we've been doing. We have 110 minus 65 divided by 65. So again, we're going to go to our calculator for this. And again, we're going to get a decimal number. So I'm going to turn this to approximately. And when we crunch these numbers, I get 0.6923. So again, I'm going to multiply my decimal number by 100 to get the corresponding percentage. And I get 69.23% increase. So I know this is an increase because it was a positive number. The 110 minus 65 gave me a positive outcome. Therefore, I'm using the word increase. So the number of necklaces that I sell increased by 69% approximately. That's pretty good. This problem also hints at something else that's pretty important. So here we're talking about what kind of increase we have in sales for a decrease in price. As you can imagine, this is something that economists and people in various businesses like to study to learn about how their discounts impact their sales. Turns out there's a specific calculation related to relative change that we can look at that's going to help inform decisions about sale prices and products.